Okay, so welcome, and now we're going to talk about scientific notation. Scientific notation is a way of notating either really large numbers or very small numbers that come up all the time in many different applications. For example, in physics, in chemistry, they come up all the time. Many different mathematical models in physics deal with things that are either very, very small, like the Avogadro's number, right? So, or if you're looking at the number of moles, what a mole of a certain chemical is, okay? Or if you're looking at the speed of light, right? If we look at the speed of light in meters per second, right, just for example, the speed of light in meters per second is 399,792,458 meters per second. So that's 399,792,458 meters per second. Go ahead and look it up on Google it. This is the down to meters per second. Okay. Now in feet per second, it's I think 36,000, approximately 36,000 feet per second, but I don't know that one out that many digits. Okay, this one I do know. So what we wouldn't do is we wouldn't write it like this. What we would do is we would use scientific notation. Or for example, if I wanted to, what's another one? 6.022 times, hold on, never mind. Don't want to do that. I'm getting ahead of myself. I can't think of a good number that I can write out without using too many zeros. Okay, but anyway, so this would be an example of a really large number that we don't want to keep writing out over and over and over again. Even if we rounded it to not 3, that's 2. 299. Even if you wanted to round it to 300 million, right? We wouldn't want to keep writing 300 million over and over again, right? So we came up with, or I did, not we, but scientists came up with a way of representing numbers in a compact form that is really easy to use when we want to multiply either really large numbers or really small numbers. Okay, so here's what the scientific notation means. Okay, scientific notation is in the form of p times 10 to the k power. Okay, where k is some integer. Okay, and p, okay, so k is an integer. Okay, and so this is just the symbol for integer. So, and then p is less than 10 and greater than or equal to 1. Okay? Okay, so now, how can we represent this number in scientific notation then? Well, we would want to represent it, so we want this to equal some p number times a power of 10. Well, we know we have a decimal point right here, right? Okay. How many place values would I need to move the decimal point over to get a number between 1 and 10, where it could be at least 1, but less than 10? Well, if I keep moving it over, 1, 2, 3, 4, 5, 6, 7, 8, well, if I put the decimal point right there, what do I get? I got 2.99. Well then, okay, so that gets me my p, right? But then, what would I have to do? I'd have to multiply by 10, because if I move the decimal point this way, how would I get it back? Well, I'd have to multiply by 10 to what? To the 8th, to the power of 8, right? So guess what? That gives me my scientific notation. So 299,792,458 can be written as 3 point, let's round it to 4 decimal places. So not 3, I keep writing 3, not 3. 2.9979 times 10 to the 8th. So now, the only thing you have to realize is that this number is the same as this number, right? Okay. Okay, so the question is, do you agree with this statement? That this is equal to this. This is equal to this. So if I take this, all this is saying is I'm taking this number times this power of 10. Well, what's this power of 10? This is 100 million, right? So basically I'm taking 2.99792458 times 100 million. That is equal to this. So scientific notation, this number in scientific notation is the same. Okay. Now typically we would just round this to, let's say, 2 decimal places. So this would be equal to 3.00 times 10 to the 8th meters per second. So this is scientific notation. Okay. So again, the first number has to be a number that's between 1 and 10. So it can be at least 1 but less than 10. And then the second number is a power of 10. That is what it means to be in scientific notation, period. Okay, see you next time.